Well, hello and welcome back, OT699. We've had a couple of weeks now of Python programming, and by now you should be fairly comfortable with the idea of what a programming language is and how Python works. But what we've done so far is really line by line code, a couple of very simple functions and procedures that show up everywhere in larger programs, but we haven't really created something useful yet. And by something useful, what I really am referring to is a program that actually does something that a user interacts with for some kind of a purpose. In other words, an application. So without further ado, I'm going to show you my PowerPoint screen now, and I'll get rid of my own video. One moment. Okay. So this would be the part where normally I ask if everybody can see that and if it looks okay. And I guess I'll just hope that's a yes. We're going to go over two basic things today. One is general concepts related to app design. So how the industry actually creates these things. And I'll also expand the definition of application just a little bit beyond how it's often used. And then the second part, we're actually going to build a functional graphical user interface, also called a GUI, in Python. So you'll be able to jump a few steps from line by line code all the way up to making a pop-up window with push buttons that does things. So moving into a couple of definitions, an app is really an application. It's just a short form of the word application. So it can be a game, it can be a word processor, it can even be a website with any more than just very simple text and pictures on it. I know that due to the popularity of the App Store and being able to download apps onto your phone and things like this, the word app has come to mean something on my phone for many people. But this is a distinction that doesn't exist within the developer community in general. So if you're looking for someone to program something for you, you really can't just say app. You need to be a little bit more specific because different types of apps require different expertise, different programming languages, different software. And so to give you an outline of a couple of possibilities, there's this chart on the bottom. They are usually designated or described in terms of where a user is going to interact with this particular program. So it could be on your desktop, like software, PowerPoint presentations and things, word processors, Paint, or the app itself could be written to live on the web. So this would be a web page that does everything that you would normally want to do to interact with the user. There's also mobile, and mobile comes in two different types. One is just a designation for any app that's on your mobile device, and on your mobile device means actually installed on the device itself. That would be called a native app because it's installed on the device. You don't need the internet. You can just run that particular program by clicking an icon on the interface. There's also a class of mobile apps which are actually mobile web apps. In that case, these are really web apps that happen to work well on your phone. Basically, they are websites in design, and they are a little bit interactive, so they get to be called apps, and they've been tweaked a little so that it will work and look good on a phone. A lot of people start with a website and then basically make it into an app by making it more mobile friendly and adding a little bit more interactivity to it. These are things like what Facebook has done and Flickr. A lot of these start as web pages and then become apps later. There's also a hybrid between the two that you should be aware of, where app developers make the main home of the software that runs the app be on the internet, be on a server somewhere. But there is something that you download onto your phone that allows that app to interact with your local processing power on your phone. And so these are called hybrid sometimes. But that just gives you an overview of what we're talking about. You have desktop apps, you have web apps, and then you've got at least two or three classes of mobile, depending on whether the software is installed on your mobile device, whether it lives on the web, on the internet, or whether it does a little bit of both. What an app usually isn't is command line code like you've been making. So if I write some lines of code in Python myself, I write a for loop, it spits something out, you don't usually call that an app. And that's a distinction that is made all over the place in the development community, is that usually you do need to consider a user when you're talking about an app. And speaking of considering users, one of the first things that any company would have to do that's developing software, or any innovator that wants to develop software, is answer questions like, who is this for? What does this app do? Why is this function needed? How and where should the user interact with it? Is it something that they're going to use from a computer or their phone, depending on where they are? Is it something that they would exclusively use on their phone and you wouldn't think to put it on a desktop for any reason? You also have to consider the limitations of the device hardware and software. So if you want to do something that takes a lot of processing and a lot of data analysis, you're probably not going to have that thing live on a phone. You probably want to have that on a desktop. And if you do need to have mobile access to some really complicated processing power, then you have to look into other options, and we'll get into some of those later. Also, who's going to build it? Oftentimes people come up with ideas, but at some point the transition to reality requires an actual developer, and some types of development are easier than others. If you want to do something really fancy, you probably do need to hire a professional. If all you want to do is add a little widget to your free website, you can probably learn to do that very quickly. Also, how fast does this need to run? How optimized does your code have to be? Can it be anything that you found for free online, or do you have to micromanage every little bit and piece of this thing? And how much money do you have to spend if you do need to use a custom developer? All of these things have to be answered at the outset of any app development. Now, we had talked a little bit about the users, and I want to split that up into two really important acronyms in the app development world. One is user experience, UX, and the other is user interface, UI. The user experience is really going to be what has grown out of marketing, essentially, but it's more than that. You're doing a full psychological profile on the end user of your application. You're trying to figure out what the daily life of someone of that particular group that you're targeting is like. What are their problems? What are their obstacles? What would they enjoy doing a little bit more conveniently? And oftentimes you have to go beyond a simple focus group where you ask them, would you like this or would you like that? Many people will smile and nod and say, oh, that's a good idea, but then they don't end up buying it. So there's this whole art form that user experience people go through, where they try to extract information from people without directly asking them, would you like this as a product? They go through a kind of interview where it's, what is your life like? What are the things that are blocking you? They kind of guide that conversation towards basically having their interviewees tell them what technology they need. And then they can be absolutely sure that what they're sending over to the developers is something that really does fit a need. And then once you do get some kind of a prototype, you have to test it over and over in an iterative process. So you're going to be testing the usability of anything you make at every stage. The user research has to be in and renewed at every phase. That might be a really good idea, but a particular implementation just angers people. You know, the people that you were making some reminder for example, say it's for the elderly community and you wanted to make a little app to remind them of when to take medicines or something. If you did that, but then you made the interface extremely small and didn't consider people with bad eyesight or with failing motor control due to various disorders or anything like that, you would be way off the mark. So these user experience people are really interested in getting into how exactly are you going to use this product. The user interface people, they're more looking at the actual visual design. This is, where do you put the buttons? What colors are the buttons? How big are the buttons? All that kind of stuff, as well as branding, layout, icons. Can you match your phone's app to your Twitter, whatever handle? All of these kinds of things are the user interface. And the user interface people in desktop world oftentimes will start coding, or they'll actually start considering the actual computer software a little bit more. In the web development world, that's a little bit split, and we'll get into that a little bit later. Now, I described a little bit about a hierarchy of iterative processes where you start at the very basic level with general user profiling. This is a kind of flow chart here that is used all over the place, but everybody has a slightly different one. It's sort of like each company's secret sauce is going to be their conceptual model of how user experience workflow works. But basically, all of them need some kind of profiling of the overall goals that gets more and more specific. So particular functional scope of your app is going to be after what is your daily life like. And then after that is information architecture. So that is, I want to have this be all one page, or I want to have them clicking on lots of buttons. I do or don't want to scroll to get to new information. That's what I mean by information architecture for the site. And then you'd have to get into the page structure. So any given snapshot of your site is going to have a look and feel to it, and you want to make sure that works well. And finally, you get to the surface level, the skin, the visual design. And that is going to oftentimes require handing things off to a graphic artist who can make things really, really pretty. And depending on the company and the workflow, you may not actually need to do this until the very, very last stage, because oftentimes you can get a fully operational working app and then beautify it rather than spending a lot of time beautifying something and then figuring out actually users don't like that button there that you spent all this time making pretty. You wouldn't want that, right? So that's kind of how this process works, is it goes from very general to much, much more specific. There are some software packages that are available that make this a little bit more clean and have started to introduce some new vocabulary into user experience and user interface design. And these exist kind of in that transition between the two. So at the user experience level, you have to do a lot of brainstorming. So this means everything from Post-it notes and whiteboard scribbling to actual software that basically makes Post-it notes and whiteboard scribbling digital. And one of the best is probably Miro. If you go to Miro.com, you can try that software out. It actually integrates your typical sticky note concepts with flowchart design with teleconferencing. Trello is a simple version. Basically, it's a board you stick sticky notes onto and you can upload things. This is good for handling teams. So you'll be able to design, okay, for this app, I need the user experience people over here to be researching the people. At the same time, I need the people who are going to be developing the architecture or the software to be over here doing their thing, and they're going to integrate with each other and this or that way. This is what you need to do from the user experience level. For the user interface, the real key word here is wireframing. Wireframing means that you're basically sketching out the look of each page. And for here, I've shown an example of a phone app being wireframed. So this is going to be a phone, which is just a rectangle, with a wireframe, which is just a Sharpie sketch of what you want on there. And then you can make that more and more complicated, higher and higher level as you go. There's actually a pretty neat video from one of the companies that makes wireframing software. It's just a 4-minute thing I'd like to show you just to kind of give you an idea of what this kind of world looks like. The guy's kind of got a cool thing going where he inserted a video of himself into a wireframe just to show you what that looks like. So I'm going to show you that now.
Hey, are you new to design, or maybe not even a designer at all, but you find yourself responsible for making a digital product or experience? Maybe you've heard of wireframes, but really aren't even sure what they are. Well, let me walk you through some examples right here on YouTube to help explain them. But first, let's define what wireframes are. At Balsamiq, we say wireframes are a simple sketch of a user interface, and they can be used for a variety of reasons. We're going to use the same principle for why wireframes are so effective by showing you what I mean instead of simply talking about them. When I say go, click on the full screen icon located over there, and we'll change the screen to wireframe mode. Then I'll show you what wireframes are and why we use them. Okay, I'm going to give you a few seconds to find that button. Okay, ready? Go! Whoa, look at this. A much simpler form of a website, right? It doesn't look like a real website, just, the structure of one. Just black and white colors, lines and shapes, some boxes and scribbles. We do have some text in here, but maybe it's not final yet. It's just a simplified version of a real website. All right, let's switch back to the full Fidelity site, and you can see the difference. See? It's pretty much the same, only pared down. Okay, what about this? It's a simple marker sketch, but you can still see the structure of the page and how it's intended to work, right? All right, let's take a look at various sketches of this page in wireframe form. Nice, okay. Okay, I like this one. Let's turn this one into a mid-fidelity wireframe. This is something you can show a user, client, or a stakeholder and get great feedback on your idea. Usually we create a few screens of this to show people how they can move through it. That's what we call a user or wire flow. You know what, let me just show you really quick. Okay, so a user is going to land on this page, or either 1, search for a new video, 2, leave a comment, or 3, click on a new video to watch. See, I just walked you through what that would be like. Okay, check this version out. Look at all that detail. It looks almost like a real website, right? Well, this is an example of a high fidelity wireframe. We combine these with annotations when we are sending a site off to be coded by a development team that typically doesn't work too closely with the designer product team. If there's limited communication between the people building the site and the designers, they need lots of details in order to ensure that they're making the site the way it was intended. All right, let's switch back to mid-fidelity. See, mid-fidelity wireframes are great for showing people your idea. They're super quick to make, and they make your idea real-ish, enough to get that feedback that's critical at this stage. Okay, why don't we take a look at the landing page design as a wireframe? Let's try a few new designs of this page. Okay, what if we highlight a certain video more prominently? There we go. Okay, what about having a big video area playing the video when you land right on the page? It's probably going to need a mute button, but you can just probably put it right there. I don't know, maybe this is too distracting. It's pretty big. You can't really see any other content, but the whole point of this exercise of wireframe is to explore as many options as you can come up with. But also try not to do this alone. Invite other people to generate ideas with you. All right, so to sum it up, sketching and low fidelity wireframes are a great place to start when you're creating something completely new. Simple is fine, it's more about the idea than the drawing. Do as many as you can. Mid-fidelity is great for when you have an idea and you want to show users or clients. Use mid-fidelity wireframes to create click-throughs or prototypes so everyone can understand how the user will flow through the software or app. High-fidelity wireframes are pretty extreme and should be used only when you're throwing over the fence for development. Okay, well that's it for me. I hope this was fun. Let me know if you want to see any more videos like this and I'll make them.
Okay, so now I can go back to the PowerPoint. I really hope that my face wasn't in the way half of that video. I realized I didn't click the turn my video off thing. It doesn't show me the video, but in the recording, sometimes it sticks your face in the middle of the shared screen if you're not careful. So if I was blocking any of that, I apologize. Anyways, moving on. We've got the idea of general user research all the way up to a wireframed out app, but now I need to make a subtle distinction. Basically, in the world of web development at least, the UI designers, because they don't do any coding or think about coding, we need to have some new vocabulary for who's actually making the app. And design usually means design in a graphical sense, not necessarily designing the software. That's implementation side stuff. And in the web development world, the next step after you get a wireframed up design is called front-end development. Front-end development is the typical normal code for your website. So this is what people do when they just want to make a website for themselves or a simple app. The software required would be the language of the browser, JavaScript, CSS, and HTML. Those are going to be the three languages that if you are making your own web app beyond free website drag and drop kind of stuff, you do need to know those languages to at least some degree of competence. And those unfortunately aren't languages that I could throw at you in an hour or two and kind of let you play with and gives you some confidence that you can build. This is probably in reality going to take 5 to 10 hours to get on top of these languages to the point where you really know how to integrate them into websites. I know some people who have been doing computer programming for a very long time. JavaScript took them a pretty dedicated amount of time to get on top of. It's not difficult, but it does take some time. Now, if you want to go a little bit more complicated and your website now needs to do something like take some user input and then send that data over to, say, an Amazon Web Services server sitting somewhere far away so that that server can process that data that was sent, run some kind of program, maybe that you have in Python, look up databases, things like that, and then send that data back to your website so that your website can display it to a user. Now, that's a different level of complicated, and that's called the back end. And the languages that you need to do that sort of thing are a little bit different from the languages that you need to develop just your own website. For this, you need Java, PHP, Node.js, and even Python will work for this. This is going to be popular in the medtech innovation world because a lot of things are just a little difficult to write front end. JavaScript is a very powerful language, but if you want to do some heavy processing, or in my case, I've worked with trying to collect some real-time audio signals, you do this kind of thing, oftentimes you need a little more processing power, and that's going to mean going off and buying a separate space on a computer somewhere else, which is a server, to do all that for you, and that's the back-end development. So remember, front end, just the website. Back end, website communicates with the outside world and does fancy stuff. Now I can show you real quickly an example of a front end website, or about where it broke in the past for me when I tried. Actually, we'll just go to a website here. Now, if you notice when I'm talking, the little blue stuff goes up and down. That's actually a frequency spectrum. So if I whistle, okay, I can't whistle. This is embarrassing. Anyways, the peak of that blue thing went down when I did that. So maybe I'll go, ooh. All right, there you go. So this website here is an old beta version of a recording app that we were making for speech language pathologists. And one of the exercises that SLPs do, especially in pediatric speech therapy, is to make them hold a vowel sound for a long time, or do a pitch slide, like a ooh, that kind of thing. And what they were looking for at the beginning of the COVID crisis was something a little bit beyond the general Zoom record, something where they could maybe record snippets of audio from a telehealth session and maybe put some notes in there, give some visual feedback through a shared screen of what the child's voice is doing. So we tried to make this, and it works like this. You can press a button and start recording, and if that's what you have recorded, it would be able to be something you play back like this. You can press a button and start recording. Again, I can take some notes here, and if they want to contact the company, they can send an email address to us, or they can download some of the data from their website to their actual hard drive. This particular, I'll close this. This particular website was kind of hard to make, to be honest. We started that app idea with just Python and pretty much running it on a Raspberry Pi, which is like an Arduino. It's a tiny little computer, tiny little development computer. Nothing you would use for anything normal, I guess. And we started just doing it through regular programming languages, and worked with some people that were good with graphical design, wireframed out sort of an idea, showed it to some SLPs at the Pediatric Therapy Network. They kind of liked the idea, wanted to test it. So we put together a website through JavaScript and through trying to hack together all kinds of things. But eventually, what I have to tell you is that that wasn't the right way to do it. What we were trying to do was a little too complicated for our expertise and a basic website. And we eventually wound up with a new strategy now that we're using, all based on back-end development. In general, I would say that for a website to become a new app that nobody's done quite like that before, it's extremely difficult. However, the idea of showing sound has been making leaps and bounds in development lately. So if you go to Chrome's Music Lab, you can just Google search Chrome Music Lab. I think I've put a link in the PowerPoint. They've done something that shows sound as well. And this is what a pro team of developers can do. So if I make this, I connect to my microphone, you can see now my voice is a spectrogram. So, like that. So that's kind of what we were trying to do on our own for probably about a year. And then these guys came up with this. So always good to not try to reinvent the wheel. Eventually, the Chrome people are making this more and more available for developers to use. So if you want to do something like with sound, this is a good place to start. So getting back to the PowerPoint for a moment. If you wanted to get into the world of web development and web app development, your best place to start is probably going to be with a free website company like WordPress or Wix. You can go to their website and there's lots of tutorials available online. It's free to try, and you can immediately have an experience of making a website using drag and drop graphical gadgets and things that form buttons and text boxes. And this is going to allow you to essentially skip having to code anything at first, at least. And then later, you can start to add more and more complexity to that site, making it more mobile friendly, adding more interactive things to it. So that will eventually turn into something like an app. And if you have a working website that pretty much does what you want, but now you want to make a product, something that you could have at the App Store to download onto your iPhone, that would require just the small step of hiring a developer for a few $1,000s, under 4,000 usually, to turn what you've already done into the final form you want it in. And along the way, you'll learn some of the internet jargon. There's a lot of it. So you'll get used to calling things like a browser that a person's using the client, and that client communicates via a HTTP or FTP protocol to your web server that's hosting your HTML code for their website, the actual code of your website, and other resources like pictures and things, and how you would expand from that front-end development if you wanted to add an extra step like talking to databases that are stored elsewhere. All of that, you can get into that in a much slower, more progressive way, I think, if you start from a basic website first and then become comfortable with the world of the internet and what it looks like from the development side, and then you can get into making more web-based apps. And there's an overview of everything that modern web development entails here. This YouTube link, I'm not going to get into it because it's a 1 hour long presentation, but it will show you at least the size of the problem and what you would generally need to know if you wanted to do everything yourself. Now, just because web apps are a little bit complicated, that doesn't necessarily mean that you're stuck with just designing them. You can actually make interactive graphical user interfaces that do things, but you'll probably just have to use a general programming language. And that's totally fine because general programming languages can make graphical user interfaces. Python can make graphical user interfaces. And for hacking and innovation and competitions and things like that, it may actually be better to start by building a working prototype on your desktop. And then if it looks good and people like it, you can always convince people to pay you to develop it. And that would mean turning around and going to the JavaScript developer or the full stack developer. I don't think I mentioned that word full stack. Full stack just means front end and back end. Everything that you could possibly want on the internet. And also, I should point out that computers are not being replaced by phones completely yet. It's oftentimes the case that when you say app, people think you mean iPhone. But in reality, app is just application. It can go on any platform. And to be honest, computer technology is accelerating so quickly that now Windows and Android do make phones and tablets that you can run essentially desktop programs on. So now computer technology meant for desktops is becoming mobile just because the desktops themselves have become so small. Now Python is what you're becoming a little bit more comfortable with throughout this course because it's a general programming language and free. And that can actually make graphical user interfaces with push buttons that do things, and we're going to go over that a little bit. But before we do, I should just point out that Python actually has lots of different libraries, which are sets of functions that you can download and use, that let you make graphical user interfaces. Some of them are going to be very user-friendly, some of them are not. The big list on the left-hand side here are all of the Python associated libraries that you can use to develop apps of varying kinds, some a little bit more focused on a simple mobile type of device, some more desktop for science and data processing. The largest and best library for GUI development in Python is PyQt5. It's the most well documented, the oldest, the easiest to use out of these. It's also fairly friendly across platforms, but we'll get into some of that later. And it's also becoming increasingly Android friendly. The developers have actually made it so that you can deploy a program that you've made in Python on your desktop to a fully standalone executable file, and that can work on just about anything now. The professionals have made it so it can work on an iPhone or a Mac or a PC or an Android. If you were to try to do that, though, there would be lots of bugs because when the developer says they've done something and it's possible, that means it's possible for them, not normal humans. So I have to say that if you're going to get into that, you may need to consult an expert. For just turning something you've written on your own computer into a standalone program on your own computer, that's pretty easy. So PyQt5 again is a library, so you would open Python in any development environment that you'd want, Spider or wherever, and you can import PyQt5 as a set of functions that now you can use in your program. That PyQt5 library has a neat designer interface that we'll get into, and basically it allows you to create widgets, which are little buttons and text boxes and things like that, in a very graphical way, and then go into a Python program and tell pretty much the GUI what to do. When you press this button, do this function. And there's a lot of tutorials online for this. I'll get into navigating some of that online content a little bit later, but I've put a link here at the bottom of the page that shows you how to make a calculator using Python. So now we're going to make a graphical user interface ourselves. So this is probably a good time to pause because we're kind of transitioning away from concept, and now I'm going to open up some windows and things on my computer and actually write a GUI that when you press a button, it makes a little text box. Well, I'll show you. It's a counter, so you press a button and a little and a number keeps incrementing by 1 every time you press the counter button. In the PowerPoint, I have all of the steps that I'm going to go through with arrows and text, but I'm going to go through it now in the recording, just writing it from scratch myself. The idea here is that you should try to follow along if you can with your own programs open and try to see if you can go along with the recording. If not, take some notes. You'll have access to the PowerPoint presentation. What I would like you to do is create yourselves on your computer what I'm going to create here in front of you now, and try to have that ready and running on Thursday. So I'm going to escape out of the PowerPoint presentation now, and we're going to start by going through the process of making I guess, the interface itself. We're kind of on that UI design phase now. So first, make sure that you open up the Anaconda Navigator. The Navigator might look a little bit different on different computers. So I'm about to open up a new program that doesn't have an icon. So we have to do this in kind of a weird way. In Windows, what you would do is go over to the top left here where it says prompt and click launch, and it will bring up a terminal like this. And then just type the word designer and press enter. Now this pops up. Before we move on to this, oh, okay, well, I guess to move the window I have to say create. So yeah, create. We'll get into this in one moment. But back to the prompt. This is a Windows thing. If you have a Mac, you'll have to go to your Launchpad and type in terminal with a capital T, and that will bring up a terminal that looks a little bit like what I just had pop up with the black screen. And you're going to type something different. You're going to type open-a designer, and I have that command in the PowerPoint presentation if you have a Mac. And then what you'll get is the Qt Designer interface. By way of a quick tour, what you have on the left here are a bunch of widgets, things like buttons and text boxes, that you can drag and drop into the main window here. So things like a push button and a checkbox and a radio button. You can, I'll try to make them a little bit bigger right now. You can just click on them and drag the corners just like any other thing. And if you want to see what that would look like in action, if you were to create some kind of an app with this, you can go to view, you go to form and preview, and it pops up with this little window that says, oh yeah, you can make push buttons and checkboxes, and you can see what that looks like. This is just to kind of get a feel for what it will look like in the end. You can also do things like, for example, there are tables, and there are calendars and labels and all kinds of things that you might want to add. There's horizontal sliders that you can move back and forth. There's dials, you get the idea, right? All right, so let's just delete these and start to make something. So let's make a very simple counter, and I'll walk you through the steps. First, we're going to want a push button. So drag a push button into the main window and resize it to make it something that you can see. Now you'll see that on the right there are a bunch of funny words, geometry and size policy and QWidget and QObject and things like that. There's a couple that you need to know. The first one that you need to know is the object name. So the computer is calling this push button. You can make it anything you want. Now this isn't the text that's being displayed on the button. This is what the computer calls that button. So let's call this is going to be a counter. So when I push a button, there's going to be a little text box that has a 1, 2, 3, 4. Every time you hit the button, it increments by 1. So I'm going to call this add_1. So now whenever the computer later in Python, when I want to talk about this button, I'm going to use add_1. Now I want to change the text to be not just push button. I want to give it some kind of instruction. So I would scroll down on the right here in the property editor, and where it says text, it's currently push button. I can change that text to be press to add, something like that. Or I could just call it counter. Let's call it counter, a little easier. Counter. And I don't know how big your computer screens are, but that's still a very tiny font. So I can go to the right-hand side with all these properties, and where it starts talking about fonts, Let me find it. Now, my ability to search up and down is, okay, so right here, font. If you click on font, and there's 3 little dots right next to the dialog box that comes up, it'll have a pop-up window that shows you all your typical fonts. You can pick which ones you want, whether it's bold, whether it's Times New Roman or whatever. And I'm going to make it size, like big, so I'll say 26. See how that looks. Counter, that looks better. Okay, so now that's a button. If I view what that would look like when the program actually runs, I can go to Form and Preview, and there's my counter button. All right, so now we need a text box that's going to be an input widget called Q line. Okay, so you're going to use an input widget called line edit. Drag and drop. This allows you to add a line of text. Make it a little bit bigger. This is going to be where you put the output of your counter button. If I go over to text and under Q line edit on the right hand side, I can add an initial value to this. My text for now is going to be 0 because I'd like to display that as a 0. But notice how that's really, really small. So I'm going to go back to Q line edit and see if I can find a font option to make that actually readable. It's actually right here again. Under the yellow part, this is the Q widget properties. Click on font. Go to size 36 again and see how that looks. Okay, that's a little bit better. So that now looks like something that I can see. And you might also want to add a label that tells people what to do with this. So this is a text label over under display widgets. And I'll go back over here, make the font something legible. That was probably too big. Better. And as far as what text you want in it, you can go find a thing called text on the right hand side. And I'm going to, instead of calling this text label, I'll call this press button to add. And I need to resize it so that all of the text is visible, like this. And the one thing that I didn't do yet was, remember how when I clicked on this counter button, the object name was something generic like push button, and I wanted to make it more functional and something I could remember, so I called it add one. Well, this text box is just called line edit, so that's kind of useless. So I should probably call this current count. Because this is going to keep track of the current count. All right. So this is the basics for what we would need to make an initial user interface. Now, if you go to File and Save As, you're going to have some options for where to put this file. I would recommend that you find your OT699 folder, which for me is here. And I've got some things in here already. Don't worry about that. I'm going to overwrite an old thing called demo.gui. You would just write demo.gui and hit save. Okay, so I overwrote an old one, but it'll be new for you. Call it demo.gui, capital D, capital G. You don't need to put any anythings in there, just write demo GUI and then enter. And in your OT699 folder, there will be a .ui file called demo GUI. Now let's put this off to the side. And the next thing that we need to do is open up an IDE for Python. For us, that's going to be Spider, because that's a good one that comes with Anaconda. So I'm going to go to the Anaconda Navigator and click on Spider. And it's thinking. All right, so I'll expand this out a bit and get rid of all of that. First thing to know, in the Spider IDE, you're going to need to make sure that whatever program you write is, for a GUI at least, is in the same folder as your .ui file. So that means you want to make sure that you are not in this case, it defaulted to my like a Spider Pi3 folder up here in the bar here. Well, I don't want to be there. I would like to be in my actual Spider folder. There's an easy way to get there, for now at least, which is I've sent you a file called starter GUI. And if you put that file called starter GUI into your OT699 folder, then what you can do is go click on this open icon in the top left-hand corner, go to your OT699 folder, which is somewhere. Why don't I have an, oh, here we go. And open starter GUI. All right. This is, as the name implies, a little bit of code that will get you started. For Python to use that .ui file, it first needs to import the library PyQt5. So that's the first couple of lines here, as well as a couple of other little things that you don't really need to worry about. These import statements will always be here whenever you're making a GUI. We can add some others later, but for now, you just keep those as is. Then what Python does is it creates a class called UI, and you don't really need to know the details of what a class is. I think conceptually it might be best to consider things like variables as books and a class as more like a bookshelf. So in this case, the bookshelf is actually going to be that whole user interface that we just designed. Boxes that go places and can be pressed. That whole architecture is going to be the class UI. The next three lines essentially just go fish in your UI file and pull all of the important stuff out that Python needs to create an actual representation of what you did visually in code. You don't need to see that code ever. It's doing it for you behind the scenes. In the middle here is where you're going to put all of the stuff that you want your GUI to do. So if I push a button, do this. All of that's going to go in the middle here between the dotted lines. Finally, I have a little bit of text in the bottom that you don't need to touch except for if you have a Mac, what you're going to want to do is uncomment the app.exec line on line 35. 39, sorry. That means just getting rid of that # right before, or the hashtag, I guess you call it now. The hashtag right before the app.exec statement. Make sure that once you've uncommented it by deleting it, that it's lined up with window, the command above it. And then if you have a Mac, take the next three lines and comment them out by putting that hashtag in front of each of those lines, 40, 41, and 42. For Windows, you can leave it as is. This has to do with launching the app. You'll find in the various interwebs when you're looking for help on GUI making, everybody's got a slightly different ending couple of lines. I believe these are the most general and should work for the most people. There are little bugs between different operating systems. For example, for some strange reason in Windows, Spider has a kind of an issue when you're using PyQt5, so that's why these last few lines are needed in Windows. In Macs, there's something else completely different, so you may or may not have to tweak some of this depending on what you're doing, but for the most part, you should be able to start any GUI that you've created with this page right here. And so that's exactly what we're going to do right now. The first thing you're going to want to do is separate out what you're going to create from what's in front of you right now, because you don't want to touch this. What you should do is go up to File, Save As. Now you should be in the OT699 folder, and I'm going to call this demo GUI.ui. This is just demo GUI. I'm not going to do the .ui because remember, that's the actual user interface you created in Designer. This is going to be a .py file. So I'm going to just say demo GUI and then save. Now this program is demo GUI.py for Python. You don't need to name them the same thing. I'm just doing that to make things a little bit more convenient. But don't think that you need to name the .ui file the same as the Python file that runs it. You don't. What you do need to do, though, is go down to line 23, where it says your UI name, and tell this program that we're creating which UI file you want to create. In this case, it was called demo GUI.ui. So then, once you've done that, you've now told Python to go into demo GUI.ui and create a kind of behind-the-scenes code for everything that you did visually. The next thing that you need to do is actually start telling Python which of the various things that you'd like to do should be attached to which buttons that you created. So let's see how that works. First, we need to take that button that we created, and remember that object name for the push button was called add1. So the computer's name for that button is add1. And there's a specific way that I would tell Python to go get that. First, I'm going to type the word self. You don't have to worry too much about what that means, other than that when I'm saying self here, I'm telling the computer that whatever I'm doing now has to do with something attached to my user interface. So when it's created this class, it's now defined a way to attach things to my GUI. Functions and math and other new variables and things like that can be attached to that GUI now. And so I'm going to say self.add_1 dot, and then what you have to usually look up in the documentation for PyQt5, but you only have a few of them that you would need to memorize, so it's not too bad. The way you say, if this thing is clicked, do something, is to say self.add1.clicked.connect. So clicked.connect means now connect Python to this button. And then in parentheses, which it kind of creates for you, you would then tell it the name of a function that should run when that button is clicked. In this case, you would use the self again, and I would name a function. So I'm going to call this counter_function. I haven't defined it yet. That's coming up. So arbitrary name counter function, but functional. This line of code now says when the add1 button is clicked, run the function self.counter function. When you've done that, the next step is to go through any other buttons or widgets that you have and do something similar. We only have one, so now we can jump straight to the final step, which is to tell Python to show the actual GUI. And that's going to be self.show, and then open parentheses. Literally, it means show yourself. Okay. Now we need to go down and define counter function. Counter function is now going to be one of the functions within the class UI. So we're going to indent it the same as this other definition here. Start with def for define or definition, counter_function. That's the counter function that I named right here. So counter function, and then we're going to pass one argument in. Argument means input to a function, and I'm going to pass self in. Basically anything that you've connected to the GUI, any variable or function or whatever that's stuck onto self is now going to be accessible within your function. And all the stuff that you want to write about what to do inside your function is going to be underneath and indented from the DEF line. So it'll start here underneath the C. What we want to do is extract the text from that text box. And remember that text box was called current count. The object name was called current count. And it turns out that the way that you can extract data from a text box is with the command self, again, dot current count, the name of my thing there, dot, and here's where it says what to do, text, and then open parentheses like that. That will extract whatever text was in the text box called current count. Now, it's going to extract that text as text. And remember, you can't add a number to a letter. So right now we need to just quickly turn this thing into a number so that you can add 1. You can do that by converting it to an integer, int, open parentheses, surrounding this entire thing. We'll take that number that is in the computer's eyes a letter, and it will turn it into a number, add 1, and then we'll give this a name. We'll call it new count equals whatever was in the text box plus 1. Now the second line that we need to do is, oh, it says I didn't use new count yet, but that's fine. So the next line of code that we need to do is to put that new count back into the text box. So the way that you would do that is go back to self.current_count, and then instead of saying .text, which extracts the text, now we're going to set the text. So current count dot set, capital T text. So current count dot text, and then inside we're going to add new count. But remember, new count is a number, and we want to put a letter in there or a character or string. All we have to do to turn new count into a string is write the letters str and then our variable. So now we have said set the text in current count to the text version of your new count number. Okay, now as a final thing I'd like to do to just as a sanity check and for fun, I'd like to, when I click this button, print something out to the console so that we know that everything's working, we can debug a little bit. And I'm going to add one fancy step too. There's a cool function in Python that tells you what the time is right now when you click a button. So in order to get that functionality in your program, you need to go back up to what is currently line 16 and type import time, because now Python can access time because it couldn't before. So we're going to make a big print statement here. All you do is say print and then parentheses. In single quotes, I'll say counter says colon space space. And then after that single quotes, I want to add some numbers and some other strings into this one line of stuff that's going to get printed out at once. And remember how you can do that by the plus sign. And now I'm going to add whatever was in the text box. I can say counter says self dot current underscore count dot text. Same command as before. So inside the print statement, I'm saying get whatever the current text value is. This will already have been incremented by 1 because that's what the previous 2 lines are. So now I'm just in this print statement saying, tell me in the console over here what was in the text box of my GUI. Then I'll add one more thing and say at time, and the plus sign again. Now I want to know the current time, so I can just say what the current time is. And the current time will be a number, and I'd rather just print this all as a string, as text to keep it consistent. So I can say str time.time. Time.time, by the way, I think I have to import it here. So import time time is going to give me this big long number. It's in seconds, but you don't know where it starts in the universe. So time is really fun to use when you're doing things like clicking as fast as you can. Like say this was a test for bradykinesia and Parkinson's disease, and you want to see how fast they can click the button in a period of time, or how fast they can click it 10 times or something like that. You could subtract each button count's time from the previous and get seconds as that time interval between clicks. Something like that could be useful in a health tech sense. You can also, there's some other ways you can get the actual clock time, but this is the most common for various things, because usually you're looking at intervals and not what time it actually is right now. So I'm putting that over there, and once you're done with all of this stuff, this is called demo GUI already, so I can just save again, or Control S in Windows, make sure everything's good. And what you're going to want to do is to press this green button up in the toolbar. Now for me, this is what popped up. And if I click the counter button, it increments the counter by 1, and it says, counter says 1 at time blah, blah, blah in the console. Now I've noticed that should be another space here between 1 and at time. So I just go down to the print statement and add a little bit more space. Between these things. Like that. The space between the 1 and the at time is here, by the way. I'm just spacing out more. So now if I run this again, looks a little bit better, nice and neat. I can set this back to 0 just by highlighting it, clicking on it, and it'll start back at the beginning, because remember, I'm always getting what's in there now and adding 1. So that is a GUI. So now that I've gone through that procedure, that's the main functional thing that I'd like you to have done for Thursday next week. And in general, I think that this should be a good frame for you to learn a whole bunch of other Python, because now it's going to be a little bit more fun to make Python do things when you push things like buttons. We didn't really go into very many cool looking visuals though, so before I let you go for the day, I'd like to show you a couple other little tricks in the graphical editor here. There are visual or display widgets that exist for no other reason other than to look cool. So I can do things like drag a horizontal line in if I want to separate out this line from others. So I separate like a top and a bottom of a control panel, for example, something like this. And if I want to make it wide enough to actually see, over on the right-hand property editor thing, there's something called line width here. It says 1 is really small. So I can go try some different line widths and say, okay, there you go. Now that's going to look a little bit more cool. And there's another trick that you can do where you can add pictures. So what I would do is go to display widgets, drag and drop a label, just like that button press to add was a label. I do the same thing, make it a little bit bigger, like this. And I'm going to add a picture into this frame instead of text. So first, let me find where my picture is. So first I'm going to go to the property editor or property menu, and there's going to be some thing called QLabel here. Right underneath text where I would normally change the text, there's something called PixMap for pixel map. Something kind of magic happens when you click underneath auto text in that empty row of data next to PixMap, and there's a little drop-down menu. If you click on that drop-down arrow, you can choose a file. Now for me, it's already going into the OT699 folder. And in this case, I have a .jpg file that I pulled off of the internet, copy pasted into Paint, saved as a .jpg, and put it in here. Since it's a counter, I took the count from Sesame Street and I put him in here. And see how he's a little bit small there? You can play with whether you want to scale the contents by clicking this little scale content button and make a count. He likes the counting. Now, if I save this, one thing to note is that I don't need to change my code at all to run this. Because this picture is in my OT699 folder with everything else, I can now go to the Spider main window here for Demo GUI, run this program again, and now the picture pops up. There he is. So you can play with this. There are a lot of different things that you can do. I'm going to put up just a few more slides, and then we'll be good for the day. Okay, so hopefully you're still seeing all this. A couple notes moving forward when you do want to look for other functions and other cool things that you can do in a GUI. There's a lot out there. One of the better tutorials is this website here, shown at the bottom. It tells you a little bit about each of the different widgets, for example, and how you can call them. For example, that stuff that I was talking about with, oh, you're just supposed to know it's .setText or .clicked.connect. A lot of that is just an attribute of each widget that is something you can find by pretty much asking the internet, what do I do with this widget? How do I get the text out of this kind of text box? And there's usually some answers for you there. Keep in mind, though, when people post things like tutorials, they don't necessarily try to make everything they're saying be platform agnostic. They're kind of, some people only use PyQt5 and they don't use this designer app. So sometimes you'll see people constructing every little box and thing totally by hand. So there'll be all this code that says make a box, make a button. You don't need to do any of that if you're using designer. So you have to filter through a little bit of that, but you should be able to find the basic functions for each of the widgets that you can drag in and create a cool looking design that way. Just a quick Google search pulls up a ton. If I just say PyQt5 documentation PDF, you can see there's lots of different things from lots of different places. So all kinds of things that you can do. And one example of what you can do if you want to make things move a little bit in the direction of more complicated, I suppose you could say. I made a toy GUI that we'll go over it a little bit in class just to show you what I did and how. But basically, this is the same thing we just made. A little bit done up, I suppose, but I found a record function that you can use in Python. Basically, I just said import this record library, and then in the function for this push button, I said start recording, and in the function line for the playback button, I said playback what you just recorded, and there's even a sound. So if I record audio, I can record 3 seconds of audio like this, and then play it back, and record 3 seconds of audio. Okay, so I kind of talked a little bit too long there, but if I want to plot the sound wave, I can hit the plot button, and this is the actual waveform of the sound wave that I made in that recording. One thing about the plot thing, we'll see how it works. We've run into a little bit of trouble. Some Macs have no problem with this, and some Macs do have a problem plotting like this. So we'll see how it works and move on from there. I think it should work, but there is a small variation in the first couple lines of the code that you need to make if you have a Mac, and that is commented in line 24 to 26 right now. We'll cross that bridge when we get there, and we'll see how many people have Macs and how many people's Macs need further debugging for plot statements. So far, though, this is the kind of thing that you can do. Is pretty much possibilities are endless. We'll, in class, even do a little bit more, get you a little bit more used to combining typical Python code with user interface design. and we might even get into a little bit of general user experience, user interface design in a more conceptual way, as well as the coding. So with that, have a good week. See you on Thursday.